Hi, welcome to my channel, where I share my knowledge on programming with Python and OpenCV. Today, one second. There, that's better. Alright, today we're going to learn how to apply a face blur effect to our custom face detections. Okay, so today we're going to just be using our previous face detection package. And in particular, we're going to look inside here. We will be using the Frontal Detector and the Mesh Detector. And in both of these modules, we're going to slightly alter the classes such that their face detection can provide an additional option, such that the user can either do typical face detections with the bounding box empty, still showing the person's face, or you can apply a blur effect, which is what we're learning today. So we'll be running in our entry point module the detect faces webcam here. We don't alter this at all. The only, so we don't alter our detect over webcam function, but we do have to alter main. We'll see why here in a minute. Basically, we have a variable called effect. We set this equal to a string that reads the text blur. And then, as you can see here, both of our detector classes accept now an effect parameter. And this effects parameter currently can either be set to none for our typical face detections or to this blur string to apply our face blur effect. Past this, we still pass to our detect over webcam function the detector as before. So let's go into the hard detector and see how we change this first. So this is our frontal face detector module, which uses the Viola-Jones HAR frontal face cascade to perform face detections. Now, I did add a scale class constant here just to make all of the formatting follow the same trend of having class constants to define when we're drawing text on our screen. But that you don't need. The one thing we do need in the initialization, as we saw when we initialized these classes in our entry point, is we have to add an extra argument for this class. This class is initialized with this effects parameter. And we're going to go ahead and set the class's self.effects parameter to effects. Now, we'll see why we got to do this in a minute, but it has to do with how we apply our blur such that we can either choose none or blur when we are passing our detector into our entry points detect over webcam function. Moving on. So detect faces. We didn't change anything about the way this method works, except for when we draw rectangles. So we gray our frame, we get our faces using our detect multi-scale. Watch the previous video if you need any information on that or a better understanding. We go into detail there. So the only difference here is now in our loop. So when we loop through the XY coordinates and the width and height of the faces detected, we're going to go ahead and set these equal to a list that we call dims. And then this list is going to be the dimensions of the rectangle bounding box. So we want to get this so that we can pass it into another method, such that we can have our blur effect applied if the effects parameter of this class is set to blur and not none. So that's where once we get our dimensions, we go ahead and call our self.drawRectangle method. This is a new method we'll look to next. But before we do that, I want to mention that we changed our face count so that it uses an F string here. It's just a more modern convention for Python strings, and it has been for some time. I'm just trying to start kind of working into it a little more and implementing it as a standard. Past our face count, we're going to do the same for a variable we call effect text. So we want to apply this to the frame so that we know whether we're going to be applying a blur or none. You don't need this. I just think it looks nice. And that's about all I need to say about that. So we define this variable as a string, and then we put the text the same way we did for the face count, except just slightly under it. Now, this is where we add a new method called drawRectangle. This method takes in our frame and our dimensions, which was the list that we get when we loop through our faces detected with our HAR cascade. So we want to use exception handling here. Just in case errors are encountered, we know to look into this method for debugging. So we're going to go ahead and try and unpack those dimensions into 4 variables, x, y, w, and h, as we did when we drew our rectangles with our typical face detections in the previous video. So this is where the effects parameter comes in. Now, if you remember when we were looking at our entry point module, we initialize our detectors with an effects argument. And this can be either set to none for our typical detections or to a string variable that reads the text blur with all lowercase blur. Now, this is where this self.effects comes into play, because once we unpack our dimensions, we're going to go ahead and check if this parameter is none. If it's none, we're going to go ahead and just draw a rectangle as we did previously in our loop to loop through our face detections. Now, past this if, we have an elif, and this is where we apply our blur effect. So pay close attention here. So if self.effects equals blur, then we want to, instead of drawing a rectangle, first calculate the start coordinates and the end coordinates of that bounding box. So we're going to go ahead and get the end coordinates, since the start coordinates are already our x and y variables right here. So we'll go ahead, and if you knew, you saw before here, x plus w, y plus h, that is our end coordinates. So we simply call that x2 and y2, and we set them equal to x plus w and y plus h. If you don't understand that, again, previous videos, we go into more detail. Please check them out. So after we got our start and end coordinates of our rectangle, we're going to apply a blur effect by creating a new variable called blur image. And we're going to set this equal to the OpenCV's .blur method. So I have some information here on this method, but we are only concerned with passing the frame and this k size parameter to the blur method. Now, to avoid a complex description, this k size argument is what represents our kernel size. And now, the kernel is what is actually applying our blur filter to our image. A greater k size equals a more intense blur. So we have it at 50-50. If we set it to 100-100, we'd have a far more intense blur effect. So with that scale, we have our frame here, and we're going to use slicing. So slicing we discuss in my stream bottom camera Tello video. And as pertains to this video, when we specify the frame, we have those 2 brackets, and then we go y colon y2 comma x colon x2. That is what's specifying that we want to slice the section of our original frame from the starting y coordinate to the ending y coordinate of our bounding box, and then from the starting x coordinate to the ending x coordinate of our bounding box. And by doing this, we slice out our detection rectangle, and we apply the blur effect with the cv2.blur method. Now lastly, after we do this, we have to set the detected area of the frame equal to the blurred image that we got from the area. So what this is saying here is somewhat the opposite of what we did, but not really. So we created a blurred image of that section of the frame. Now we're going to go ahead and take the frame, and we're going to set that same section from the start and end y coordinates and the starting x and ending x coordinates. We're going to set that section of our frame equal to that blurred image. And that's it. We don't return anything because we're calling this in our detect faces method, which is called in our detect over webcam method function in our entry point module. And this is where the engineering comes into play, and we engineered all of this in such a way that we don't return anything, and all of these flow very well to achieve our desired effects. So, and if an exception occurs in either of these, we want to know which method the exception occurred in so that we can debug. And that's it for our hard cascade and the adjustments made to apply a blur. Now, let's look at the mesh detector. In the face detection package, we have the MeshFaceDetector module. Again, we add a constant for scale here just to have all of our formatting follow a similar trend. And also similar here, we add an additional argument to our initialization. We call this effects. We also set this to a class variable called self.effects and equal to whatever the class is initialized with, either none or blur currently. That's all we've changed so far. In detect faces, we go ahead and we convert our image from BGR to RGB, and we process it for results. We then going to check if we found any results, and then we're going to loop through the face landmarks of those results found. That's all the same as before. And then we also have a change in this method as we did with our frontal face class. We call self.drawRectangle. And here we're going to pass in the frame and the face landmarks detected, which if you see here, that's what we're looping through. And if you want more details, again, previous video, go into a lot more specifics. Now we're going to go into that draw rectangle method in a second. But again, I'd like to point out we use f strings now for our face count, and we define effect text as a string variable, which we then use to put this text on our frame that is displayed for us to see. Now, following this, we have our newly created draw rectangle method. This takes in our frame and our face landmarks. And as before, we're going to go ahead and do this complicated math to get our bounding box coordinates. This is an important time, or a good time to point out an important fact that the MediaPipe's face mesh detector does have a draw rectangle method or get rectangle method. I'm not sure on the naming exactly. That would streamline the process of getting this bounding box, but it's a lot more fun to learn how it works, how we go ahead and slice through the image to get that box. It's not slicing exactly, but it's a similar process to how we do it. Now, if you want a better explanation of this, see my previous video where we go into detail on this module before we added this face blur. So after we get our bounding box coordinates, we're going to go ahead and check again if self.effects is none. And if it is, we draw a rectangle the same way as we did before, no effects. And then we're going to go ahead and check the same as we did in the other class if the effects equals this string that is blurred. Now, if it is, we're going to do the same exact thing to apply our blur effect. Nothing different. We're going to go ahead and slice out that part of the image, which is our bounding box, and we're going to go ahead and blur it with our OpenCV's blur method. And then we're going to set the portion of the frame where we got this blurred image equal to the blurred image. That's it. We use exception handling again in case we need to debug this at all, but we don't. It works. You saw it in the intro and you're going to see it again next, because we're going to go ahead and demo these over our webcam for you to see this cool face blur. Come with me and watch what we did. All right, we're ready to demo both of our detectors with our blur effect applied. We're going to start here by running our HAR frontal face cascade detector with the blur effect, and then we'll do the mesh detector. I'm not going to go into a deep analysis of these because we do a deeper analysis in our previous videos on each, the frontal face and the mesh face detectors. So I'm going to go ahead and play some nice little bit of music, test these out. We'll see how it looks. Let's do it. So I've commented out the mesh detector so that this will load a little faster, because when we run that version, it requires a lot more resources. So here in a second, we should have things popping up. So that's our HAR face blur. It's not the best at keeping the detection, or should I say not the best at tracking our detections. So let's go ahead and press Q to exit out of here. We'll go ahead and just stop the program altogether. Then we're going to go ahead, we'll uncomment our mesh detector, comment out our HAR detector, and then we'll just change here and detect over webcam the detector to our mesh detector. Let's go ahead and hit run again. Then we'll wait for it to load. This one is really good because it does not require all of those frontal face features, but in fact has key points on the sides so that we can pick up that detection. So even at my side here, or at least as far as I can tell until I'm turned out of view, it's holding the blur. That's pretty good. So now we've all seen how it's done. We've applied our face blurring to our custom face detection classes. Now, if you like this video, I'd appreciate it if you like, comment, subscribe, all the works. It helped me help you by putting out more content that you guys like. I hope. Given that, also, if you would like any particular content, tutorials, whatever, let me know. I'm happy to oblige. And until next time, have a great day.